And Raphael, you found a button for join the queue, which is whenever you got a question, or then you can just click on it to remove yourself from the queue. So that's typically the way that we interact in the IETF, right?
So I think it's time. Benoit, do you want to give a few seconds or a minute more, or what do you want to do?
Right, because actually I'm looking at the list of participants. We're missing Nacho, who needs to present, and Michael. So I would give a minute or two.
Yeah.
So I see Michael, and we're missing like Nacho from the presenter list.
Okay. Are we good now? We have Nacho, right? Do we have Nacho?
Yes, we do.
All
right, very good.
Hello.
Great. Hello, everyone. Okay, let's get started. So thank you, everybody, for attending the Knowledge Graph Interim, part of the NMOP working group. I'm Rishad, and I'm the new co-chair of the working group, with Benoit also present, who you know very well, I'm sure. Okay. So this is the note well. I won't read it. I'm just going to wait, a few seconds. People should be aware of this, especially take a look at the first 5 bullets. This applies for people who are new or fairly new to the IETF. So I'm just going to pause for a few seconds here. And the most important thing, is, to interact respectfully, disagree with the idea, nothing personal. And in case people didn't know, this meeting is being recorded. Okay, so I'll go to the next slide. So here's the agenda, just a few minutes from Benoit and myself. Then we're going to have a presentation which we've titled Education from Raphael. Thank you, Raphael. Followed by Benoit, who's going to talk about some business justification of knowledge graphs. We have 3 documents on knowledge graph right now. So we'll get presentations from various authors, Michael, Nacho, and Lionel. And then the last 20 minutes, we'll be talking about what are the next steps and brainstorming, and how do we want to proceed further. Any questions on the agenda? Everything good? So the meeting objectives, is to educate the audience on knowledge graphs. I know there's some experts in the room, but there's other people like me who are just vaguely familiar just from a high level. So the education is very important. on Open Semantic Web, terminology, etc. We're going to have the presentation on the 3 knowledge graph documents. And then I said, brainstorming, okay, next steps. So on this, we have a final slide, which we'll be presenting later. So I'm just going to change deck. And I think, Raphael, you're the next one, right?
Correct.
So for all the presenters, we'll be sharing the slide deck and you will have slide control, right? If you're new to this environment, feel free to ask any questions. So the presenter could say if they allow the questions during the session or if they prefer in the end. The way to ask questions is to join the queue, right? There is a small hand icon at the bottom. Now, we're not formal about the process. We're not too many. So feel free to also just unmute and ask your question if you think this is relevant. Only in case there is too many people talking over each other, we're going to reinstall the formal process. So let's keep it informal if it works. Thank you.
So I have a beginner question, sorry. How do I progress slides?
You should see arrows at the bottom of your screen.
I don't, but I'm seeing Lionel Tayada at the bottom left, which is not me.
Okay.
Now I see. I see. Okay, great. Okay, so on this, thanks. Welcome and good afternoon, everybody. So I'm new to this group, although I follow by a distance a bit what was going on since around a year, but mostly just looking at the mailing list, etc. So my task today is to provide a lightweight introduction to the semantic web. And before this, I would just present myself. So I'm Raphael Trancy. I'm a professor in computer science working in Eurecom, which is a graduate school in digital science in general. And I'm leading a research team there. And my research expertise since about 20 years is around semantic technologies, knowledge engineering, also information extractions and natural language processing, and recommended systems. And so I have been asked today, and I was very delighted to provide you with this lightweight introduction to the semantic web. So obviously, the semantic web stack is a bunch of, I would not say it's complex, but it's generally, at least in the academic domain, something that you teach for easily, the course can easily be 20, 30 hours. So packing this in half an hour would mean that I would just have to be very fast forward on some aspects and giving you just pointers and hints enough to understand the raw idea. Before this talk, I was just querying ChatGPT with this prompt. If I have to give an introduction talk about semantic web technologies to this audience, what it should be. This is what ChatGPT come up with, even with timing on some sections. This is not exactly the outline I would follow, but I was pleased that most of the things are indeed covered to some extent by my talk. So to understand semantic web technology, I will go very backward 26 years ago. Let's see how the semantic web initiative has started in Europe and in the US. And for that, you have to go to the very beginning of the DARPA demo program, so circa 1999. And I'm borrowing here nice slides by people who have witnessed this era, this epoch, in particular Peter Clark, who is now a senior researcher in the Allen Institute for Artificial Intelligence. And that was one of the slides from 99 that was trying to justify why we need new technologies to make sense of the very fast-growing amount of information that was going on the web. And one salient sentence taken from this slide is, the problem is computers cannot process most of the information on web pages. That was a statement that we made at that time, 25 years ago. And that has led to the birth of the semantic web idea, where we need to do something so that computers knows more the information that is available on the web. So there was a seminal article in 2001 published in the Scientific American. She posed that this is the article that presents the semantic web idea. And in this article, you have basically two big pillars. One, which is knowledge representation. The focus is how you should represent knowledge so that machine understands it. And the second pill, which was underdeveloped, was this idea that we will have ultimately autonomous agents that will make use of this knowledge represented and do things with it, actuators, if you want, autonomously in an autonomous way. These days, I would say that we'll come to this at the end of my talk. In the LLM era, we are putting again the spotlight on the autonomous agents now, considering that the last 20 years was heavily made on the knowledge representation aspect. This was also one of the conjecture of Ora Lassina, who gave a great talk at ISWC last year, which was more or less showing how we went through the knowledge representation way to now more autonomous agents. Again, in the education part, I really like this documentary, although it's 15 years old. It has been made by an artist that was going on and interviewing how the semantic web idea was perceived, again, 15 years ago. This documentary is 15 minutes long, and it's worth a watch from my point of view. Now, what has popularized the semantic web idea is Google. When in 2012, they published this blog post introducing knowledge graph, things, and not strings. And what that meant here is that a lot of the information on the web was so far only considered syntactically, fueling search engines, but never really semantically. Like before, we were not trying to disambiguate while the language is, whatever language you're talking with is naturally ambiguous. This effort that Google was actually embracing since a number of years was now popularized and publicly made available via this blog post. And quickly, people see the results. So, for example, if you take your favorite search engine, not necessarily Google, by the way, and you ask who is the daughter of Marie Curie, what you will get is not only those blue links, now those info box panels that give you more details about the key entities that you formulate in your search, but directly the answer to your question. In this case, you see Irène Joliot-Curie and Eve Curie are the two daughters of Marie Curie. And how Google knows this is because he has a knowledge graph that materializes a world view with common information about people, about places, about organizations, about products, about recipes, about many, many things. And it can just, in addition to rely on its index, also directly go to the knowledge graph, get the attributes value that matches your queries, and inject you the answer directly. So some definitions, the semantic web is not a revolution, it's just an evolution of the World Wide Web in which we want that the meaning or the semantics of the information and the services is explicitly defined so that basically other programs can make use of it. It can be a better search engine, but it can be many other agents that consume this information and do transaction, negotiation, all sorts of services. It derives from the vision of the inventor of the web, synchronously, and in a more concrete way, because that was a task that has been standardized by the World Wide Web Consortium, WWC, within the semantic web activity. More concretely, it's a bunch of specification of standard, RDF, OWL, Sparkle, Shackle, RML. You will get familiar with all those acronyms that basically tells you how you should represent the information, the schemas, query this information, etc., etc. And it has been, of course, largely adopted by the industry. The semantic web is often seen via cake. Actually, there have been many cakes that have been proposed, or layered architectures. So those are some examples of cakes that you may found. And you see each time, you really see this notion of layers and things that are on top of other things, whether you see that in 2D or in 3D form. So this is the idea of this layered technology. Another way of putting it is that the semantic web, the web is a puzzle with many key technologies. The three at the center are really the main piece of the web: HTML, HTTP, standardized by IETF, and URI that you need to address resources on the web. You have a bunch of other stuff in gray that I'm not talking about, the XML galaxy, for example. And then you will see here the key new pieces brought by the semantic web activity with those keywords: RDF for having data representation, OWL or RDFS for doing schemas, Sparkle for doing queries, Shackle for doing validations, and on top of this, inference rules so that the machine can reason. So let's start with RDF. RDF stands for Resource Description Framework. What does it mean? Resource means anything that can be addressed with a URI. So of course it can be a resource that you have on the web, a page, an image, a video, a sound, but it can also be any real world object for which you would like to give it a URI. Description means that you will describe this resource with attribute values, relationship with other resources. And framework, because RDF at the end is a model. It's not a format, and I emphasize this. It's a model, a graph-based model that have many syntaxes to be represented that materialize those descriptions. So more precisely, RDF is a triple model because we consider that every piece of knowledge can be broken down into a triple. The triple being a subject, a predicate, and an object. So the predicate is like the property, and the subject and the object can be seen as node. So we can say that RDF is also a graph model that enables to link description of resources. So this is what you often see when you think or abstract what RDF is about, is really this graph idea, where nodes will represent resources and where properties, so the edges, between the nodes, will correspond to predicates or properties that tells you how those nodes are, that could be attributes, so that could be true relationship between nodes. And again, RDF is a model, not a format. You can find plenty of serialization of RDF in JSON, in JSON-LD, in XML, in plain text formats, in many formats. The other particularity is that in RDF, every resources and the properties, so the nodes and the edges, will also be identified with URI. And in RDF, we would say that the value of the properties can also be literals, like a string of characters, an integer, a Boolean, a basic data type, if you want. That brings to another core principles of the semantic web that Tim Berners-Lee has written down into a design issue note back in 2006, which is called or referred to the linked data principles. Those are like the 4 commandments of the semantic web. What are they? First, that you will use URI to identify anything, and not just documents. I really mean anything. The true Eiffel Tower in Paris can have its own URI. There's not a problem with this. Now, the second principle is don't use plain URI, but try to use HTTP URI. By this, we meant URI that can dereference, that of course, people will own domain name, have control over those domain names, and can do things when we want to dereference, do an HTTP GET on those URI. Now, if we do so, an HTTP GET on those URI, we need to get something. So what you should get? Again, the third principle says you should try ideally to get an RDF description of this thing. So if I'm getting the URI that describes the Eiffel Tower, I don't expect the Eiffel Tower to disappear from Paris and appears in my living room. I expect to get a description in RDF of the Eiffel Tower. And ideally, this is the fourth principle, I would like that this RDF description contains itself links to other RDF entities so that you can follow your node and then build this global giant graph. So those are the 4 principles. And that was again popularized by Tim Berners-Lee in a big TED talk that he did, where he was really calling everybody to now push your data out on the web in this RDF format, so that the next generation can build tons of applications that reuse those data. The very first nucleus of that movement, at least in large scale, is generally known as DBpedia. DBpedia being the RDF version, the very first RDF version of the famous Wikipedia encyclopedia. So originally, DBpedia was just a community effort between two universities and one company that says, in Wikipedia, regardless of the localization of Wikipedia, so the language of Wikipedia, there are more than 250 different Wikipedia. They all have infoboxes on the right for the popular entities. And all those follow templates. So can we build a system that just reads this template and write this information in a structured way in RDS? That was DBpedia. And quickly, that does go fast. So for example, this is the info box of the city of Bogota in Colombia. And you can have the same information here represented as tabular data, but behind this is a graph. And again, remember the linked data principles. Actually, when you, in this case in DBpedia, they don't create one URI per entity, but they create three different ones. One that represents the real thing, and you see that in the URI because this is a slash resource. Now you will never get the real thing because that, for example, here is the real Eiffel Tower. So this resource, when you want to get it, will always redirect to another URI, in this case, either the slash page, which corresponds to an HTML document, or to the slash data that corresponds, in this case, to the RDF description of the page. How you enter this? Well, this is very famous in the web architecture. You use content negotiation for doing that. This is something very made from the start. You have the 303 or the 301 code that tells you permanent redirections or just the other to redirect your original get to a different URI. So from this report, we see plenty of linked data appearing everywhere. And people have even tried to track this down. Each bubble here represents a data set that can be sometimes very large, meaning millions or hundreds of millions of nodes, and interconnected with each other. So that has grown, and since now 5-6 years, we stopped growing those clouds because they are impossible to fit in the screen. But just to let you know that there are a lot of data out there represented into a structured format, interconnected to each other that you can query. To some extent, that shows some success. That's why these days we talk about an era of knowledge graph where a large number of companies, regardless of the activity sectors, have developed in a private or in an enterprise way or in a private way, some sort of knowledge graph. And you see those pictures regularly displayed as example of knowledge graph. Another popular one is obviously Wikidata. I talked to you about DBpedia, that was like the first effort, but now Wikidata is established as an official sister project of the Wikimedia Foundation that represents all the information that you can find in Wikipedia, but in a structured way, with graph form and the forms of attribute values. And actually, the model of Wikidata is a bit more complex because they feel that the subject predicate object was too simplistic for representing complex information. So Wikidata has created a model that is still compatible with RDF, but that already starts to show that sometimes you want to say things about the property. For example, here, we want to say that Douglas Adams has been educated at St. John College, but that was just for a period of time. So you want to add what they call qualifier to express during which temporal period Douglas Adams has spent some time in St. John College or in another school. And those qualifiers are like attributes on the property itself, in this case to say the start time and the end time, or the academic major or the academic degree that he got at that college. So this ability to say something about the predicate has created a lot of tension in the semantic web community. And that was also another strength of a competitive way of doing graph, which is also known as labeled property graph or LPG. And up to now, there have been quite some fights between those two ways of representing information using either RDF or LPG. And more recently, let's say since 3-4 years, there have been efforts to reconcile both worldview. There will be an RDF 1.2 that will become an official recommendation in a few months that basically enables what LPG used to do, being able to tell something about aging. But LPG has a lot of other problems. LPG, for example, they don't really put focus on getting a schema as an effect. They don't try really to have unique identifier for every node in the LPG graph, which means that when you need to merge two LPG graphs, you suffer basically because you can have identifier collisions and so on. Even if they try to catch up now with this stack, which for me will clearly push you to say that what LPG is doing is not really a knowledge graph. It's a data graph where you have little or no semantics because you have no schemas. So another strength of RDS is that what you use for modeling your graph is anchor into schemas. So let's talk about schemas. In the semantic web terminology, schemas are called ontologies. So ontology, of course, may be a word that scares you because it's like coming from a philosopher and Aristotle and ancient Greek time. But in computers, it's very a concrete artifact. It's an engineering artifact, actually, that consists into a vocabulary that will enable to describe a particular view of some domain. And generally, that consists as an explicit specification of an intended meaning of this vocabulary. So that means a consensus, a shared understanding of what we need in this particular domain and how we should name it. Okay? So ideally, an ontology captures this shared understanding, and it provides a formal and machine-readable model of that domain. So modeling ontologies is an engineering effort. Sometimes people will even say it's like almost a piece of art because you don't really know how to do it. So there have been attempts over the different decades to provide methodologies to build ontologies. In the 90s, people from Boeing and IBM were already designing methods for or guidelines for how you should capture the knowledge of a domain and how you should represent it. A bit later on, back in 2005, so 20 years ago, people from the ontology engineering group at the Polytechnic University of Madrid has created this meta-ontology that was famous, and there have been plenty of tools that have been generated for trying to help how you should structure your information into a taxonomy, how you should validate that your ontology is consistent, is clean. So you see a bunch of tools. But more recently, let's say since now 5 years, we have a very solid methodology, industrial methodology, known under the terms of LOT, for linked open terms, that provides plenty of tools for visualizing, publishing, editing your ontology, validating your ontology, and good examples to follow. So I would say this is today the de facto most industrially mature methodology to follow when you have to build ontology. In terms of approaches, there are many ways to build ontologies. In some domains, it may be useful to just start from text. There are tons of documents that describe processes, things, and for which you can just put these days a language model, or at least some natural language processing software that will analyze all those texts and extract what are probably the most important concepts and relationships and start doing the design of your ontology of your domain. So ontology learning is a big research active field. Ontology reuse, it's another obvious thing to do. Before designing a new ontology, let's search if one does not exist already that potentially partially cover your needs. So for that, we need directories or registries of existing ontologies on which you can search, catalogs if you want, that you can search for existing schemas that maybe have been already published that cover what you want to model. And often, even if you see partial ontologies that match your requirement, or you have text on which you could run some natural language processing, you still need something more to properly capture what your ontology will be used for. And often that amounts to capture what we call competency questions. I put an example link so that you see what I meant, but in short, it means that you have end users that will not necessarily see the ontology, but instead have practical demand on what they would like to query, to ask from the model to perform. So they express these needs in plain English or in plain French or whatever language. And you, the knowledge engineer, try to transform this demand into a model, and then you will verify that you have actually queries that you can express that answer that question. So this is what we call an offering test. So this method is also regularly used when we need to do models of new domains. So the 101 building ontology, but that works in some cases, in particular, when you need to scope the domain, clarify what would be the purpose of the ontology, what are the expected type of questions that the ontology should answer, also know who will maintain the ontology, then try to reuse definitions of existing terms, enumerate those terms and classes, define attributes and relationships, and then fill values for some of those instances or example instances of some classes. This is generally the 101 method we suggest. And there are tools or editors that enables actually to develop those ontologies. So I mentioned here Protégé because this is an open source free tool that exists since now 20 years. It's not the only one. You have other industry pay license tools that are provide other type of guarantees and qualities. But yeah, so you have some tools. I would say nonetheless that they still very much constrain the ontology engineer in, for example, seeing a hierarchy of classes or properties as a tree, which is of course more limited than a full graph. So you have a bunch of limitations with those visualizations. There is one ontology that is dominant across the web giant, is schema.org. This ontology is massively used by all search engines, and actually the search engines are encouraging any web developers to include some schema.org markup into the page to facilitate the work of the search engine in indexing, in understanding the resources that they need to read. So schema.org now is a large ontology composed of more than 1,000 types and more than 2,000 properties that describe everything which is related for the search engine, what matters for the search engine, like events, organization, person, places, products, review, etc., etc. And we have different registries or directories that index ontologies with some level of quality. So I point you to this log catalog, linked open vocabulary that was part of the ones who have set it up already 15 years ago. More recently, in Europe, you have this standard ICT portal that also try to do this manual work of doing a large-scale inventory of existing and adopted ontologies in all activity sectors. So they published this general overview landscape of ontologies. This is the latest one published this year. It's like a 70 pages document on which they will give you a minimal information card about ontologies that have been reviewed manually in many, many sectors. So you will see IoT. The IoT is a strong proposer of ontologies, cloud computing, blockchain, energy, smart grid, robotics, supply chain, manufacturing, mechanical engineering, material science, bioinformatics, agriculture, and many, many sectors. So maybe this is also one shop go to see what ontologies you can find. There is, in the ICT domain, the DevOps infrastructure ontology catalog that have been made by a collaboration between Huawei and, again, this ontology engineering groups in Madrid. and more details about how those different ontologies here, it's a catalog of ontologies, fit together. So I point you to the paper to read more details. Of course, we can mention the Noya ontology developed by mostly Lionel Tayador, who is in the call today and may talk about it later, which again, it's another view of an ICT system from the incident management point of view, and what are the key elements you need to materialize in the ontologies to typically deal with an incident management system. So the notion of travel ticket, etc. And here you see that this ontology follow exactly the good practices in reusing existing ontologies and building some glues between those different ontologies that they import. So this is all the ontologies that are reused here. Okay, I talked to you about data. I talked to you about schemas. I finish now with the third part, which is querying. For that, there is another standard called Sparkle, like the sparkling water, which is the RDF query language. So Sparkle allows for query to, so a query in Sparkle consists of a triple pattern with conjunction and disjunction and optional patterns. You will find implementation in any programming language. It's very rich. And actually, Sparkle is three things. Many people think it's just the query language, but it's two other things. There is, of course, the standardization of the result format, but that is secondary. But the most important thing, it's also an API, in the sense that it's also an access protocol, so that you can query distantly any Sparkle endpoint in a standard way. So we will see that in a second. So an anatomy of a query, for anyone which is familiar with SQL, while Sparkle looks like very much the same, you will have this select, from, where, and a bunch of triple pattern clause that follows, with at the end some modifiers, adding by, order by, limit, etc. So really same stuff than SQL. I skipped through those details. Sparkle does more than just select. You can also construct graph dynamically. You can directly ask questions on the graph, and you can get everything about the particular node. This is the described construct. You have filters with all sorts of logical, math, existence, tests, regular expressions, everything you can imagine to navigate the graph. And of course, you have aggregates naturally if you want to do count, sum, min, max, average, etc. And you have, because this is a graph that you need to traverse, this idea of property path that you can say from one node to another, or with choices, alternative paths, etc. You can represent all those expressions in your query. Another big strength of Sparkle is that it enables as well federated queries. You don't mandate that the data is centrally stored somewhere. It can be distributed. And your query, okay, you have to force that with the service keyword. You can decompose your query into multiple parts that will each eat a different endpoint, and then the Sparkle service will federate the results. So this is pretty a big strength as well. And of course, you have crude operations if you want to insert, delete data. And like I said, it's also a protocol, so you can just do a get. This is standard, the /Sparkle $query equal the encoded query, the encoded Sparkle query into the URI, and then you will universally receive the same response. So you have some parameters besides the query, but this is minor, and you can use the get, the HTTP get, or the HTTP post if your query is too long because you're limited in the URI size. Okay, I need to, I think I have what, 3-4 more minutes. I should be able to end. I talked to you a lot about those three key technologies, RDF, OWL for schema, and Sparkle for querying. There are plenty of methods for now developing knowledge graphs. Those methods are often discussed within this community, knowledge graph construction, here within the W3C. This is also an academic community. I know that many of you have already participated somehow in this community via talks or just participation. Often the knowledge graph constructions, when you have to do that, in particular, if you start with some structured data already, your database, for example, you may want to have what we call direct mapping, so a direct language-specific implementation, programming language-specific implementation of your transformation from your original data to RDF, to this graph shape, which can be materialized or just on the fly, mediated, for example. But you have also a declarative way of doing those transformation, and that often goes from a language we call RML that enables to write declaratively those transformation rules that are then executed by a rule engine. Those slides are nice, but I will skip them. There are just two examples of large-scale knowledge graphs in sectors that are somehow share some particularity with the network sector. In this case, vehicular data with a signal from the vehicles and the energy sector. So I'm just skipping that, but you have the slides if you want to go through them after the talk. I'm happy to answer questions. I want just to come back and finish with this. I'll start with this slide, saying that the problem is that computers cannot process most of the information on web pages. Of course, these days, I would challenge this statement, because probably if you put into the picture ChatGPT and the like, you have to replace the cannot by can, right? And those tokens swallowers, like I would call them, they just swallow tokens, right? But at the end of the day, you can ask whatever questions and they give you sensible answers, not always correct, but still. So it seems that understanding web pages is not anymore a problem. Do we really need semantic web technology? Yes, we do. So true. How we achieve that is because of those auto-regressive large language models. I will not do an LLM course here. You know that you have been an explosion of LLM appearing, including what we call open weight LLM. Not necessarily closed models that are just locked behind an API wall, but the true model that you can, at least you have the weights that you can onboard into your own infrastructure and sometimes fine tune or adapt them. So that has raised plenty of adaptations in many, many verticals. Here I'm mentioning math, finance, medicine, law, etc., education. I could have had telecom basically. You have also telecom dedicated LLM. A big race worldwide between those LLMs. The ones which are closed source, only available via APIs. This is the OpenAI, Claude, Gemini, etc. Garden. Others that are open weight that you can install on your machine, on your premises. This is like Llama or DeepSeek. And some that are truly open source. Those are more rare, in the sense that they also share the documents that they have been used to train those LLMs. And here we mentioned Olmo from the AI2 Institute and Claire for the French government or French association. Claire and Lucy. Okay. Now, what's the point? LLM is also used for knowledge engineering. More and more, we see that LLM can be used for developing ontologies, imagining competency questions or answering competency questions, generating Sparkle queries, doing RML rules that will convert your structured data into RDF. All of those tasks that the knowledge engineer used to do now can be boosted with LLM. And LLM are more and more capable, even if there are still some work to do this. I point you here to 3 papers I published myself last year on this topic. And there is this special issue here in which I'm a guest editor as well, where we expect, we have attracted actually quite a lot of papers showing how LLM can be used to support the knowledge engineering work. So that was my super fast intro. I'm happy to answer questions and deep dive either here or later offline into more topics if you wish, but I hope I have taken the time. Thanks.
Thank you very well. Thank you very much, Raphael. I think it was spot on for the audience. Is there any questions, clarifying question from the audience point in time?
Yeah, I just joined the queue. I have in question as an individual, how would you recommend, as you said at the beginning, it's a very big topic, you give hours of classes on this, that was half an hour. How would you recommend to the audience who wants to dig more into this? I mean, we can search online and ask ChatGPT and all that, but what would be your recommendation as to how to go a bit deeper?
What I would say is there are two excellent free MOOC on the semantic web, which I think are, they are very, so I can provide the link, they are very well structured. In particular, if you're more interested into the query aspect, the modeling schema, ontologies aspect, etc., you can just zoom more into those different parts of the MOOC. So I would say this is probably the best resource that exists. And next is to put your hands dirty and play with it. That would be my second recommendation.
Could you send a link either on the chat here or on the mailing list after, something along those lines?
Yeah, sure. I'm doing that right away.
Thank you. Any other questions?
Boris.
Yeah, hi.
Hi.
Maybe kind of stupid questions. Am I correct what knowledge graph is very like universal concept or architecture or framework, so it can be used for anything, like for networks, for vehicles, for any kind of let's say structural data?
I would say this is a true statement, indeed. Most of the industries which I have worked with have now developed some sort of knowledge graph. Often, this is a way to have structured data layers on top of a data lake, plenty of documents or other type of structured data that was sitting there, and that provides a layer on which additional services can be developed. So it's often used for data integration. That was actually one of the very big first original motivation for developing semantic web technologies. But these days, it's more and more useful for, in this vision where you have more and more autonomous agents that have specific capabilities in doing things. It's a way of anchoring common knowledge on which they can tap into and perform services. So I would say yes, for many, many sectors, you find those knowledge graphs that just anchor the minimal worldview we need to understand each other.
Okay. Are there any tools for for playing with ontologies? Maybe you can suggest something.
But by playing, you mean developing?
Yes, creating, yes, in any way.
Yeah. So I mentioned Protégé because I think this is a tool that many, many people have used. I would not necessarily say it's the panacea. I think still we have to figure out what's the right UI to develop ontologies. I think we haven't found it yet. So there are many attempts. There are tools existing. I'm afraid that none of them are really completely satisfactory. But maybe in the short future, we don't really need those tools because maybe a conversational interface is the way to go.
Okay. And last question, if possible, is RDF the most used or most popular way to implement ontologies in practice, or it's just one of many?
It's not the only way, but I would say it's the most common one. Schema these days, also because many big industrial players are pushing for it, use some sort of RDF. Okay. Again, RDF is a model. It's this graph-based model. You can have specific adaptations. We know, for example, that Amazon is doing some specific both at software and even hardware level, because they use it very at large scale. We have heard that all the supply chain delivery of Amazon is managed with RDS. So you imagine the number of billion of nodes that it has to scale. So they have dedicated ad hoc implementation specific for being able to scale. That they don't reveal exactly the secret sauce of this. But at the end of the day, it's some sort of RDS.
Okay, thank you. Thank you so much.
You can go, Nacho.
Hi. Thanks a lot for the presentation, Rafael. So since you concluded with a few slides about LLMs, I cannot resist but ask you, what do you think about these recent discussions about LLMs versus knowledge graphs? Some people say they could be complementary, others that they could fight each other, no? You could give us some thoughts on this.
Yeah, so one of my active research direction is on those graph RAG systems. So actually, where I believe they complement well each other. LLM needs to have, I mean, the way they generate answers, what you would like to control is the source they use and the factuality, how factual they are, right? So for this, there are plenty of mechanisms in trying to give them better instructions, in constraining the context, or feeding the context with the relevant piece of documents. So this is typically a RAG architecture. But nonetheless, that decreases a bit the volume of hallucinations they can have, but it's not completely annihilate them. I do believe that LLM with knowledge graphs are best equipped because the knowledge graph often can provide straight answers. It's also more, by the way, environmental friendly. The LLM is the hammer, and sometimes you just need not a hammer for a tiny simple answer to questions that a query in a database will provide. So for me, merging property, knowledge graph, and LLM is the way to go. Now, how to do it? There are plenty of ways to do it, and this is an active research area at the moment.
Okay, thank you.
Thank you again, Rafael. So we're going to jump to the next part. Thank you, Benoit.
So thank you for presenting this educational part. I think it was well received and spot on for this audience. Now let's discuss some more networking, right? And maybe some potential business justification why it might be the right way forward, this knowledge graph. And part of this was presented in NMOP's IB workshop, which is of management operation last November or December. So I would need the slide control, so I could give it. So you have to give it to me, Rashad. So you go under my name on the right-hand side.
Yeah,
and,
I gave it to you.
Okay.
No.
So I start with a picture from a NOC. I mean, so Rafael, this is our world, right? A NOC. So it's just a series of windows. And those windows are somehow not connected. They monitor different things, up to where you see maybe a TV channel to see if there is like an earthquake or something happening in the news. So this is our world. Now, this should be easy, right? We know about networking. So let me take a very simple concept, an interface, right? Show IP interface. Great. We've been doing that maybe if you've been touching routers. Now, this is a CLI. Now, if I go into a different screen, this is maybe a syslog message. And the syslog message says, this is the gigabit 4/1 on that router. Well, it's actually GI 4.1, not gigabit, not gigabit Ethernet, not, okay, so there is no naming convention, just English or Chinese or French or whatever. Now, let me take MIP. So I could be querying via SNMP MIP modules that refers to the interface, which is the IF index. Great, so there is a model there. It's the unique number, blah, blah, blah. We know about this. Easy, right? Right. Now, what is this one? This one is Yang. It's a Yang module. Yes, we were clever enough to use the same IF index number, but if I recall correctly, the key is the leaf name, right? Or actually, the name is different there. Okay, and the name is again a string, so there is no formatting of gig, giggy, gigabit Ethernet, whatever. So that's why we have different screens, right? Now, okay, maybe I'm monitoring like data plane information IPFix. What do we see there? Well, it's actually called ingress interface or egress interface. So yes, this is the same IF index number, but there is some extra semantic. You know, if you're receiving packet interface or sending packets on that interface. So again, slightly different. The IF index is the same as the two previous slides. Great. Now, what if I take different data models? The top one is BGP flow spec. The one in the middle is TAGAX plus. The one at the bottom, this is radius. Well, I'm actually talking about the same interface, but the format is different, the model is different, the encoding, well, less important. And not even talking at the bottom about the Yang interface instance mapping, which is like between service model, between network elements models, or between whatever models. We just say it should be an interface. What I need is to say this is like the same instance that I'm using in the service model and into the device model. So just a stupid example like the interface is not that easy. And that explains maybe why we have all these screens in a NOC. And I could be taking any other examples. What's a network element ID? Is this the management IP address? By the way, still IPv4, so the loop back, right? We still do management over IPv4 and v6. Or maybe the DNS name? Or maybe this is the CMAP ID or a UUID that comes from a different database, which is the inventory database. Or if I speak IPFix, this is the IP address of the outgoing interface on which the packets are sent. Because in my time series database, this is the unique ID that tells me this is the router exporting. Now, let's discuss network prefix, an event, network anomaly, incident. That's why the NMOP terminology was somehow important. A service. What's a service? We could be discussing for hours, and I did speak about service for hours, service definition. A customer, a topology, etc. So somehow all these concepts that we believe we know needs to be formally described. Now, maybe you heard I've been stressing Yang in the last couple of years, right? I'm going to stress somehow the opposite here, that Yang, even if it's a good data modeling, will never be the solution to everything in operations. Not everything will be in Yang. We're not going to change all the data modeling from an IPFix, BGP flow spec, or BMP, whatever, into Yang just because we need to aggregate and correlate the information. Practically, it's a dream. The life cycle operation are so long that it's not going to happen. And I'm not even sure it makes sense. But the issue is that if you see from the list there, we have different data sources with different formats. And the cost of doing this integration of data model is very high. And that's why we're reaching the limits of Yang, right? I could cover that in more details, but let's skip for now. The thing is that we need a way to have the knowledge of the relationship between all of these objects in a machine-readable way, which is what we learned in the first tutorial. The fact also is that the operators, they already have a data lake of some sort. I've never seen an operator telling, oh, I'm not collecting data. So, and it's a lot of data coming from management plane with Yang, coming from control plane, for example, for BMP, with data plane, NetFlow, IPFix, SFlow, all these data. But it's very difficult for data analysts to use information for fault prediction, for root cause analysis, or simply to find what is the issue, what is the remediation in the network. I stress that. Different data model, format, repository. That's something that Raphael mentioned. Graph, knowledge graph could go and query in different places. The inventory database I mentioned with UID, is this your time series database? Maybe not. The issue we have also is that we're dealing with different audiences. The AI LM experts don't have the knowledge of networking. So if you do a good job to link all information, it might be helpful to them. To define the right concept, it might be helpful. The software engineer, different audience, different competence. The network engineer, different competence as well. There are also different teams, right? The team doing configuration might not be the team doing the assurance. Again, can we link all this information for them? But this linking is very difficult. Correlating management plane, control plane, and data plane, this is challenging. And all these data must be linked to what? To the configuration, to the notion of service, to the notion of incident. I'm sure Lionel is going to speak about that. We must have a link to an assurance graph, to a digital map or CMAP, to a customer, because in the end, we need to map this to the business information from the operator. And obviously the intent as well, because if the goal is to solve closed loop, we need to have the intent, otherwise we don't know what to do. So what is required to solve this autonomous networking vision? Well, the data. We need to have clean data, consistent, interconnected, and with clear semantic. This is what we need. And with the context, if I'm a network operator, I need to know if a router is an access router, or if it's a PE router, or a P router in the middle of the core, or an ASBR router, autonomous system border router, because the things I'm going to ask these routers of intent, or the things I'm going to monitor will be different. So if I receive flows on a PE router, well, not all interfaces are equal. They are customer facing, they are core facing information. And if you know about networking, what you're going to receive as flows will be different. The IP addresses will not be the same, underlay, overlay. So we need to link all of this information. So NetMOP has been working on the right topics, I believe, with the Yang push data collection based on the data mesh principles, where we want to get the right data with the right metadata, with the right semantic up to the time series database. CMAP is also important as a source of information. Network anomaly and incident management, all of these are good track. But the end goal, like it was mentioned in the tutorial, maybe this is AI ops and LLMs, and potentially the ability to reason. We'll see in the future. But what we want to do first is to solve the issue of garbage in, garbage out. If we don't have the first bullet point of clean data, consistent, interconnected, clear semantics, and all this, which might be coming from knowledge graph, well, it's going to be hard to solve autonomous networking. Now, the first bullet points, it was mentioned by Raphael, we need to have an ontology. In this case, a networking ontology. The bullet point number 2, to link the data. This is the semantic web, linking information. Now, things such as different source of information, this calls for mappings. So I think this might be the right time to focus on knowledge graph in networking. Now, this somehow comes from network operations challenges that are in the draft at the bottom of the slides. And, this is what I've been trying to summarize in a couple of minutes. Data overload, difficulty to extract insight, complex correlation, correlation between customer and service, data storage formats, loss of context, etc., etc. So I propose to pause here in order to gain a couple of minutes. So is there any questions on this? I was trying to just provide a networking aspect of what the tutorial was mentioning.
No questions? Okay. Thank you, Benoit. So I guess the next one is Michael. Let me share and pass control.
Hello.
Hold on a
Camera's over
second.
here. Put screens here.
So let me give you control, Michael. 1 second.
Okay.
Hold on. Oh, I can't find you.
I'm here. Great.
Okay.
Got it.
You're getting control. Thank you.
Okay. Hi. So I suppose I don't have a lot other than maybe just to go through an outline of my draft so that everybody's kind of on the same page. Just give maybe some of the motivation that that we had for writing it, and also maybe share probably controversial thoughts on implementation. I know there are some, especially with Raphael here. I'm probably going to say some things that are going to have minor controversy, but let's go ahead. So this is just an outline, and the first part of it really is all of what Benoit just talked about, really. The fact that we have inside of the management systems that we have right now, we have already a huge amount of data being collected. We have a huge amount of models, whether it's the TMF model, whether it's the IETF model, whether it's ETSI models, whatever model that we're swimming in models. The problem is trying to connect all of that information. And this is maybe where we came to this, and the fact that not only linking, your configuration with your operational data, with your intent, which could be defined in multiple different formats, different sources of truth, different databases within most systems, whether it's in the, to talk about NORIA, incident management, you've got your trouble ticket connecting to your to some sort of event on the network, with your fault management, which connects back to your configuration. All of this stuff is there, but it's just very hard to get. And this is maybe kind of where we wanted to try and help. And so the draft, as I wrote it, and with the help of everybody else on the list, Benoit, Dan, all of those people who contributed, was to try and highlight how this approach can help, the type of things, all of what a lot of what Raphael spoke about there, and how all of those things can help unlock the information that's already there, that's already siloed within the different models. And our goal actually would not be to create new models, because there's already enough and there are already people working on models. It's really about connecting models. So a model to connect other models together. Obviously within the IETF you have Yang. Yang has its limits. We talked about that. We talked about closed loop. And then really, an overview of a knowledge graph-based framework, how it should look, how it could be used, especially within the context of network management. Something that Raphael didn't mention was the idea of fair data. Findability, accessibility, interoperability, and reusability. This is not something that is part of the semantic web as such, but it is something that the semantic web does very well. Especially through the IRIs around the naming of particular objects and making sure that they can be found, and the publishing of the schema, the reuse, and the accessibility. One I highlighted here in yellow, this is new for the current version of the draft that I'm about to publish. This was a comment by Brad, who's I see he's on the call here. This open world versus closed world. Especially in terms of people mentioned LPGs, you have the idea that you know everything about what you're doing and you can pull things together. Semantic web comes at it from the other point of view. It doesn't know what it does know, it just knows what it knows. So it's a very good solution for pulling together information from disparate sources. Now, this is not the only reason for doing this, but there are other. The key enablers here is the fact that you can create an IRI. Sparkle itself has federation built into the language, and it really very much lends itself to combining data, obviously from the web, but in our case, all of the existing NMS, EMS applications that we have outside there. One thing actually that I would note is that the databases that you'll deal when you're dealing with this stuff, it's very, very disconnected, but not so much in a bad way. So, for instance, if you have an RDF database, it's just triples, as Raphael says. The validation of that versus, say, your schema or versus your OWL or whatever other thing you have there, that's actually in most cases not there. That's a separate step, and this is where this shackle comes in. That can be a good or a bad thing, right? And generally speaking, again, when you're dealing with incomplete data and when you're dealing with connecting of data, it's potentially a good thing. So we have a chapter on why it's there, why it's good. Most of the things I just mentioned. A chapter or a section on Yang and RDF, and really, I mean, I mentioned Yang in this presentation mainly because this is where we're coming from in the IETF. But you could replace that with any model. If it's a model in another language, if it's UML, if it's TMF, if it's whatever, it can be represented in RDF and RDF schema or OWL, and it can be represented in RDF data. I have a section on positioning and architecture, and I have a slide on that in a minute. And there is a bit of a focus here on federation and pulling in data from external sources, not having to necessarily have everything in the graph, but maybe having at the graph layer extra information, extra knowledge that connects between those things. This is new. This was contributed overnight, and so we have a reference architecture diagram, and then in the original version of this draft there wasn't a lot of examples, to be honest, because I wasn't really trying to push a specific ontology or a specific implementation or a specific way of building any of these things. It's really meant to be kind of an education and to make sure that people understand what could be done. But we've added a lot of examples in at the end, just to help with understanding. This is maybe just an overview of what a kind of a knowledge-based system. Again, I don't think Raphael kind of covered this, and maybe how an ontology can help, or even a schema. So a lot of this stuff is covered already by Raphael, so I won't go into it. But if you look at a knowledge-based system, if you look at back here, this idea of monitor, analyze, plan, execute, this is very close to what we have already in a lot of our models, whether it's the TMF architecture, whether it's the, which basically looks like this, where you have the intent, which is plan, fulfillment, you have some sort of monitoring of what's going on around the insurers and digital twin. And we see the knowledge engine as the thing that connects all those existing systems. So it sits on top of what's already there. And we believe this is the only way to unlock all of these self-X requirements that we have for autonomous networks. I'm going to keep going because I'm very cool. So challenges for implementation. I think, Raphael kind of hinted to it earlier when maybe asked about questions about good tools and things like that. A lot of the tools originate in academia. They're not, some of them are abandoned. They're not actively maintained. In my opinion, and this is everything here is my opinion, there's no MySQL for Postgres, for RDF data, nothing that does the full stack. There are things out there that do a lot of stuff and that you can get for free. There are, of course, paid options. In Huawei, they're not really open to us. So my focus was completely on open source. Virtuoso open source is a very good database to start with, but in the free version, for obvious reasons, it doesn't support high availability. Another good option, RDF4J, it's got a small footprint and you can run it anywhere. I don't think Raphael went too far into OWL and the semantic and creating, a lot of extra information and knowledge around equivalence and semantic equivalence and all of these complicated logical things that you can do. If you use a reasoner, then they can interpret that and they can generate queries for you. But what I will say is that there's no magic here. All it's going to do is do query rewriting, and some of those queries can result in exponentially complicated queries, especially if you're dealing with virtual data. That data is actually in a SQL database and not in your graph. So it's something to be careful about. In general, if you look out there in the world, there is more innovation going into LPG. This is where enterprise use cases are quite strong. It has all of the problems. LPG has all of the problems that Raphael mentioned, mainly the fact of the schema and semantic. It doesn't have anything, but they are pushing towards some further standardization. They have GQL now with Cypher. So there is stuff happening. In general, these two worlds seem to be converging. You've got RDF star, which is bringing some of the LPG aspects in, and LPG themselves, I think they have recognized that they need a schema, but they don't have one yet. This is maybe just something I popped up just to illustrate what I'm talking about with respect to the ecosystem. You have these open source reasoners. They only implement certain versions of the OWL language, and there's a bunch of different OWL profiles. And in some of these cases, these projects are dead. There's a big list of them here. You can go through them. I'm coming towards the end.
Yeah, two small minutes, Mike.
2 more minutes. So I want to point out OpenSPG, because this is semantic web on top of LPG. This just shows how people can fail very complicatedly. This is a brilliant framework, but it is proprietary. They still don't have a schema that is standardized, and it shows out that we start with LPGs, but we end up with the semantic web. You just end up implementing it yourself. This is stuff that we found useful, especially for learning. You know, Sparklebook and Graph Notebook. Graph Notebook is maybe the better one because you can visualize your queries and visualize your data. These are both open source, very handy for learning Sparkle. What can the IETF do? Formalize a way to share the knowledge. RFCs don't seem a good fit, especially if we're creating new ontologies. Standardize a format, you know, OWL versus RDFS, define a way to capture additional information. We have a hackathon that showed how to do Yang in RDF. Here are the summaries. It takes a particular type of approach. We don't have a plan for IETF in Madrid, but this is something we were doing with Rafael, and I'm hoping that we can share a fairly complete, if not complete, way to do Yang in RDF by Madrid. That's it.
Any quick question? Quick one, because you want to focus on the brainstorming session and next steps, right? Okay.
I have a quick question, but the answer might be long. Is Rafael or Michael, why does LPG not have a key schema?
He's the expert. I'll let him answer.
Because LPG do data graph, not knowledge graph. They went into representing data, and it's only later on they figure out that actually having an abstraction, having the notion of schemas was important. So now they're trying to catch up, in particular with GQL. But what they are trying to do is just reinvent the wheel.
Okay.
Absolutely, yeah. The one thing, though, as I say, people, for whatever reason, find LPG easier to learn, and it is maybe, you know, Cypher is maybe slightly, with its kind of ASCII art type approach, slightly easier to use than Sparkle. So maybe the learning curve is easier, and if you don't have to define a schema, you can implement something very much faster. If you're dealing with closed data.
Okay, thank you. Next presentation then. Thank you, Michael. Nacho, you should have control of the slides now.
Yes, thank you. I see the buttons there. So thanks a lot. I will keep it short to save time for the brainstorm session. This is the second draft. Is the link. Sorry. So first, well, I would like to thank Rafael and Benoit, because you did all the work for me. also Mike, gathering all the knowledge in the first draft.
Okay,
because,
let's go on the next section.
Yeah. So this is all covered. Just remember that we replaced another draft with this one to broaden the scope.
And you're also an author on my draft. So.
Yep. So what is the aim with our aim in this draft is we wanted to, as Rafael mentioned at the beginning, to get our hands dirty and start from the bottom and understand the core elements that we need to build a knowledge graph. No? So in this process, we identify two pillars for constructing a knowledge graph. The first is the ontology development, that, as was mentioned before, here we have plenty methodologies, and in particular, the linked open terms methodology is the one that we have been investigating. And the second pillar is all the knowledge engineering, all these data pipelines for constructing a knowledge graph. No? So here in this case, what we are looking for is these declarative mapping languages that I will give more details later. So these are the two pillars that we must implement, no, in order to have a knowledge graph. So the first one is the ontology development. As I said, we are looking for standard methodologies, for proven methodologies, not standard methodologies, because first, what we want to achieve is to ease the adoption of knowledge graphs and semantic technologies. This is, for example, our case. We started with no background on semantic technologies, and it was very difficult for us. The learning curve is quite steep. So a methodology like LOT was very, very helpful to us. And also, keep in mind that ontologies are use case driven. They are meant to tackle a problem, a use case, no? So it's difficult to have or not realistic to have a one standard ontology to rule them all, no? This is what we have seen this story with Yang as well. At the end, you will have plenty of data models and you have this heterogeneity, no? So yeah. This is what we have been investigating a lot. We are following this in research projects and also internally at Telefonica. And also, this methodology has been used to develop a standard methodology, the ETSISAREF, but in the IoT scape. So on the knowledge engineering side, what we want to achieve here is the transformation of raw data of structured or semi-structured data into RDF data, so it can be part of the knowledge graph. So we could do this by implementing ad hoc components that program this transformation of the raw data into RDF. But we found that the concept of declarative mapping languages brings several benefits. The first is scalability. You don't need to develop a specific code in a programming language. You will rely on a generic engine and just define the mappings. So your data maps to the concepts in an ontology. And the second, which is also quite important, is the traceability. We want to keep observability of our data, of these data pipelines that are constructed in our knowledge graph. So in case something breaks or the quality of data is not good, we can trace it back. So we have identified two declarative mapping languages. One of them is RML, which is currently standardized within the knowledge graph construction community group that Rafael mentioned before. Here we have seen a couple of limitations regarding the available functions for processing the data and also nested data, which is the case of Yang data. But keep in mind that RML is still under development, so this is reasonable. And the second mapping language that we identify is the mapping template language. This is a template language based on Apache Velocity. If you're familiar with Python and Jinja, this is the Jinja of Java, to put it simple. And it's well integrated with frameworks like Apache Camel, and this is done in the Chimera framework. No, this language is we have been testing this language and with good results. So we're exploring both options to implement what we have here on the right hand side. No, ingest data, transform it based on the mappings, and then integrate it in the knowledge graph. So again, we wanted to be practical, make baby steps, not start with a complex use case from the top. So what we have been doing is we have been working on a simple use case. This is the network data catalog. That's how we coined this prototype, which comes motivated by the draft that augments the giant library. where we have proposed the, if you're familiar with data catalogs, we have proposed the idea of registering Yang-based devices as a new type of data source. Just like in a data catalog, you register, I don't know, an SQL database or a Kafka topic or a REST API as a data source. We wanted to do the same thing with Yang-based devices that implement NetConf or GNMI as APIs, for example. So with this simple prototype, we wanted to prove that knowledge graph can support this network data catalog. And for this, what we have done is, as I said, these two pillars. We have developed an ontology that I will show next, and also the knowledge engineering pipelines that transform the data that we collect from a NetConf server and integrate it in the knowledge graph. What we do here is we collect the Yang library data from the NetConf server and integrate it in the knowledge graph. So we know that which modules, how they're implemented by a device in our catalog. This is an example of the latest version of the Yang library ontology. Here you see some of the concepts, a combination of ontologies. It's just to give you an idea, and also important details that I want to emphasize on regarding the methodology. Here what you see is these blocks, they follow a standard notation that is called talk. That it's one of these aspects that we want to tackle. No? To, for example, have a standard notation for depicting an ontology, which is something that when we started we didn't have. No? And finally, some key takeaways. First, regarding the pillar of ontology development, as I said, the proven methodologies like that have been really helpful, but they involve several manual steps. So here there's room for improvement with automation and even LLMs, as Rafael mentioned before. You could use LLMs to generate the competency questions, and this speeds up the development of the ontology. Regarding knowledge engineering, knowledge graph engineering, again, declarative mapping languages have been really useful and scalable for constructing or creating new data. But updates and deletion of data in the knowledge graph, this is a challenge. We don't have an answer yet to this. No? And the same is for the cycle of the knowledge graph. If there's a change in the ontology or in the data source, there must be an alignment, no? A synchronization between these two pillars, the development of the ontology and the construction of the knowledge graph, no? of the mappings with ontology. And to conclude, the next steps, well, of course, draw the NMOP, the interest from the NMOP group and collect feedback. Start by understanding the core concepts and the potential of knowledge graphs and ontologies and the semantic web. Collect more use cases, but simple use cases. Go step by step, because this is a huge area of research. Perhaps, or hopefully, this meeting is the beginning of this. And I didn't provide an update for the draft, but I promise that in the next hackathon in Madrid, we'll bring a prototype of the network data catalog, so you can see how this works in a hands-on way. And also continue with liaison that we have started within ETSI TC Data group. And in this sense, we are promoting the use of LOT or an evolution of LOT has been recently published, LOT for KG, which tackles the management of the life cycle of a knowledge graph. No? This is something that we want to promote. No? So we have this alignment between the ontology development and the knowledge graph construction. And also the ontology governance, which I think Brad made a comment on this in the chat before. We have to be really careful with this. We will start developing ontologies, all of us, and we'll find the same scenarios we have seen with Yang, that we end up with heterogeneity. So there must be some level of governance so that we ensure that there's reusability and interoperability, no, between all these new ontologies. And that's it. Thank you.
Thank you, Nacho. You've gained us some time, which we were, dragging behind schedule a little bit. So we've logged the queue. Apologies to everybody, but please don't hesitate to follow up if you have any questions on the mailing list. Lionel, apologies in advance, but we're going to decrease your budget from 15 minutes to 13 minutes.
It's okay.
We just didn't do a great job managing the time. So just give me a minute and I'll share your slides. And you should get control now.
Yeah, I do. Thanks. Okay, let's go. So dear all, thank you for being here. My name is Lionel Tayarda. I am a researcher at Orange, and I'll be presenting the knowledge graph for enhanced cross-operator, internet management, and network design internet draft, currently in its second release. In what follows, we'll first provide an overview of the draft content, then delve into the specifics of this second release. So first, we have a network to manage, and because networks can be large-scale and made of heterogeneous components, we might consider building linked abstract representations of these networks, which falls within the scope of the IETF and NMOP working group, and could lead to produce graph representations, including knowledge graphs. And since many stakeholders are involved in using such graphs, multiple requirements must be addressed, such as including multiple knowledge facets into the graph for easier situation understanding, enabling representations to be shareable across practitioners, and also about ensuring smooth integration of the related technological stack into existing information systems. And to address these challenges, we've raised the ideas in previous work that first, knowledge graphs could be seen as a combination of the digital map concept with operational data and operational support systems data, and also that Yang-based configuration data could be included in the knowledge graphs to advance decision support systems and network production systems. These ideas are fully developed in the publicly available internet draft, and let's now quickly browse its content. First, we introduce the concept of IT service management knowledge graph while showing how it can be built from the heterogeneous data sources that are typically at hand for network device manufacturers and network operators, and also showing how it fits with best practices in terms of change management and incident management processes by providing in-sync representations of both the network's ecosystem and expert knowledge. And using different layers of abstraction, we define how to include Yang configuration data into the broader IT service management knowledge graph discourse domain. This means that one can query the entire knowledge graph without worrying about the specifics of each represented subsystem, thanks to a shared vocabulary, while still maintaining the ability to query these specifics via local vocabularies. And to enable achieving these ideas, we've defined 6 fundamental tasks and grouped them in a pipeline model. The set of tasks is part of a call for experiments, which anyone here can, of course, refer to and contribute to. We'll be using this task in 2 slides from here. But before that, let me briefly mention that the internet draft includes a discussion for those who are concerned about how to handle event streams along with the IT service management knowledge graph concept, and how to provide a unified access to data distributed across various technological platforms and stakeholders. We can, of course, discuss this with greater details later. So let's now move to crunchy details with the draft implementation status. As for now, we have reports for 2 complementary experiments, with Noria mostly focusing on the downstream part of the pipeline model and Yang to all on the upstream part. Next, we focus on the Yang to all approach with, for the sake of clarity, a practical change management use case upon Yang-based virtualized 5G infrastructure data. So the first step is Yang models gathering, which in this case come from ETSI standards. Next, the Yang to all converter applies a simple algebra to translate the Yang models into their equivalent representation in the semantic web technologies. And this translation includes Yang models dependencies that are computed and fetched, leveraging the Yang catalog API and other tools. Next, a knowledge graph construction step takes Yang configuration data and the previously mentioned Yang model translation to produce a 5G infrastructure data graph. And the lower lane in the diagram states for knowledge graph construction with non-Yang data, such as organization data, locations, ticketing data, and so on. Merging these subgraphs brings the IT service management knowledge graph to life. The current experimental setup relies on a Neo4j database instance and the Neo Semantics toolkit, which works well for this proof of concept, but other database system can be considered, of course. Next, business rules are applied to enrich the graph with functional dependencies between network components. And note that using business rules can be optional if configuration data is sufficiently explicit to reason on the network dynamics. And finally, the shared vocabulary enables querying and exploring the IT service knowledge graph for network service and cross-technical domain impact analysis prior to a network change operation. So to conclude, the internet draft addresses as a challenge of building an IT service management knowledge graph that uses Yang-based configuration data while abstracting network details for learning and sharing behavioral models. The draft is currently implemented by 2 complementary experiments that have been run in an industrial setting, showing relevancy of the proposal for operational concerns. The first one is Noria, which provides means for building a unified view of complex ICT systems and capturing network behavioral models. And the second one is Yang Tools that streamlines the development of knowledge graph-based network digital twin architectures. It's noteworthy that the Yang tool approach notably opened venues for having shared practices in knowledge engineering and knowledge graph lifecycle management across the network industry, as it automates the ontology implementation and ontology update activities of the linked open terms methodology, which is a well-known and acknowledged methodology in the semantic web community, as mentioned before. And to conclude, going steps further is of course possible and open for discussion here or later. For example, based on additional experiments from the NMOP working group or the R&D opportunities that are sketched in this slide and fully developed in the draft. So I am done with the presentation. Thank you for your attention, and I hope you found this interesting.
Thank you, Lionel, and you bought us 5 more minutes. Thank you. So just bear with me 1 second.
Thank you, Lionel. Nacho and Michael. So with Rashad, while preparing this interim, you have a couple of questions about should we work on this in the IETF? Is the IETF the right place? How do we collaborate? Is an RFC the right output? Basically, should we have this experiment in NMOPs? So we've got a couple of questions, but what I want to describe here, this is the charter. The charter text as agreed by the AD. So NMOP is in between OPSWG and the research group. Why? Because we deal with experiment, and we know those experiment they're going to take some time, right? The netconf yang push integration is the first one with Apache Kafka, and it took like a couple of iterations, right? Because we need to put it with code. The other one as well, anomaly detection incident, and then the next one was detail map as well. So we've got hackathon, we've got documents, we prove it works, and in the end we conclude the experiment. So we've got 3 or 4 I mentioned because the last one, which is the RFC 4545 bis, which is about a requirement. Now the charter. The conditions of the charter are open to have new experiments. Obviously, we would need to discuss with the AD for this, right? So this is the conditions. This is the situation with the charter. Now, Rashad, how do we want to go? Do we want to go with the list of questions that the two of us were asking ourselves, and we let the people discuss for 15 minutes? How do you want to proceed?
Yeah, I think if you can start with those questions, that would be good. Well,
Right. So we learned from 3 different people who've been in experiments that they're developing and working on an ontology. Is there any place on the internet where we have a networking related ontology, one that we could use as de facto standard? So you mentioned, Raphael, that a website for, there's schema.org. There is another one that lists all the ontologies. Based on the experience, is there anything we could be reusing, or we have to create our own?
There are pieces that can probably be reused. But what I would like to observe as a first question is here, I think among the 3 presentations, we see a little bit of a tension. On one side, we had the presentation of Nacho and of Michael that were more or less saying Yang provides useful constructs to understand how the models will be built, and we need one ontology that captures the semantics that Yang put into. So the notion of a module, a submodule, a container, an augmentation, etc. And that leads to the development of one ontology, like Michael showed, or a pipeline for instantiating this ontology, what Nacho showed. On the other side, Lionel says no. Yang is actually the meta part that enables to develop n models, and each of those models will on the fly be transformed into mini ontologies. This is already a tension, because then in the Lionel's case, if I understood well, you don't have a single ontology, but as many as you wish. Probably some would be more important than others, because behind there is a de facto largely reused Yang model for it. But already I'm seeing here some tension and differences. So perhaps this is already a point of discussion.
Can I jump in there? Because I don't, that's not exactly what I was saying, Raphael. So we approached Yang with you because this was kind of maybe a basic part. I think actually Nacho kind of mentioned it, the same as Nacho, you want to get your hands dirty. This is the starting point. But, I think I mentioned during my presentation, we have lots and lots of models. The telecom industry has been trying to build a model-driven engineering for a long time. There's the ONF SIM model. There's the TMF have a set of models, or APIs. APIs is much more difference. You have ETSI, you have different layers. You've got the resource layer, service layer. You've got the BSS layer, where kind of Lionel is kind of starting to go with the trouble tickets and stuff like that. There's a huge amount of models. There's a huge amount of model engineering going on. What there isn't is the fact that you know, the TMF is going from the top, IETF is going from the bottom with Yang. There's a whole bit of mess in the middle, and then there's a whole bunch of proprietary models. You know, whether, you know, you buy your fault application from Netcool. Netcool has their model. They will convert to a TMF model for converting it to there's conversions and model mapping all over the place. And what isn't there is something that traces those connections, those provenances. You know, do we need? Okay, I'm not picking on here, Lionel, but just a thought experiment. Do we need a new model for trouble tickets if Remedy already has one, or somebody else already has one? You know, Netcool already has one for faults or whatever. Is it more a case of, well, being able to express those models in semantic way, schema, and be able to connect them, and possibly, I'm very slow on this, but possibly label some of those things to be common semantic, you know, more taxonomy rather than ontology. That is where I was coming from, which doesn't mean I'm right, but it's just, I'm just fundamentally clarify that.
Oh, it's clear.
So with Rashad, we've got like a big question, which is, if we want to work on this and need to validate, what would success look like in a year or two from now? Does it mean that we have like an ontology development? Does it mean that we have knowledge, that we have mapping language, that we've got tools? What is success here? And maybe that's the most important question that we have, Rashad, right? So what is the... Okay,
Yep.
Lionel.
Yeah, my point is not about success is not developing an ontology one that fits all, but about capabilities on sharing knowledge across practitioners and improving network design, and sharing knowledge also about anomaly models and so on. So this is the goal, to be able to share. And this supposes that we use semantic models because they intrinsically incorporate translation capabilities and reasoning capabilities. That is to say, if you, Michael, want to use this and that ontology, I know how to translate it in a deterministic fashion or align it with mine, because Orange and your company don't have all the very same business goals or infrastructures and so on. So being able to share is a fundamental goal to follow, and all the rest is cherry on the top.
So now, Lionel, let's continue on this one, because we've got our area director in the call. So they're going to say, practically, what does it mean? What do we put in a charter? What are the deliverables? Sharing is a noble goal, right? But in the end, what do we do? And is the IETF the right place? And by the way, it's a question for everybody, right?
So a clever experiment could be that you, I, whoever, have some standard anomaly situation, for example. He will represent in his own semantic framework or whatever, and share it with others from the working group and tell, okay, try it with your own framework. And do you see the same behavior? Do you have the same root cause analysis? Do you have the same network automation results and so on?
I think there's two different things here. One is I completely agree with what Lionel said about sharing knowledge. I think this is the important thing, right? But then it's like, well, how do you do it? So you kind of have to agree a format for sharing of knowledge. You know, and there was an email thread with Brad, who's on the call. Feel free to chime in, Brad. But about, you know, using OWL, and then it's like, which version of OWL? And I was like, well, you know, some of them are implemented this way, some of them, you know, there's no reasoners. So there's a little bit of a mess, I would say, in that world. RDFS is something simple. it maybe is not expressive enough for some of the use cases though. So this is an important thing to kind of trash out maybe. It's like, well, you know, I think, is it OEL, the biologists kind of chose as their kind of standard, and then they went with it. You know, maybe there's something in there. So the format of sharing knowledge is one thing, and then I suppose maybe it's kind of representative use cases, which is not maybe one specific working group. You know, is it the, you know, the people that want to understand? I know that there's another group, for instance, looking at the mapping between L3SM and L3NM. You know, that's a very good use case for what we're doing. It's a relationship between two different models. They happen to be all yang. Capturing that knowledge and capturing that knowledge in a format that is easy to share, as Lionel said, that's a very good use case. But you kind of have to go on a case-by-case basis to find more places like that. And then the last thing I would say is is stuff outside of the IETF, like you know, connecting models, connecting IETF models with let's say Broadband Forum or TMF or whoever. You know, there are different kind of things there with some sort of semantic equivalent. You kind of need to pick something that's of high value. So in one thing is the format of how you define it. How you do it, is an RFC the right way? Probably not. None of these ontologies that Raphael showed earlier, none of those are in an RFC. They're all living documents that are updated. Actually, Lionel actually just said that, you know, about how stuff can grow and the concept. And then picking a use case. That's my 2 cents.
So I'm sorry to interrupt, but in case not everybody saw it, there's a show of hands, and I see that Brad is in the queue. Brad?
I was just kind of responding to Michael's segue, I suppose. I think.
Yeah, invitation.
That discussion was literally like, you know, between our RDFS, there's pros and cons of each, but it's almost underneath the need, right, in terms of how do you actually share knowledge and the concept. Because it's like saying, I want one programming language, right? And there's lots of different programming languages out there. But I suppose that the question is, as Lionel said, right? How do you get to a point where you can actually share the knowledge rather than actually define, you know, which programming language are you going to use? I suppose that was just my point, Michael. Because there are things that are easier, I find easier now than trying to do an RDFS, right?
Yeah, absolutely. But the important thing though is we have to agree. Otherwise, if it's like, you know, this is the reason I kind of popped up that slide about reasoners. You know, you've got a whole bunch of different reasoners supporting different versions. Well, some of them are dead, some of them are not. You know, there's one thing describing the model, and the other thing is then trying to be able to use it in open source or. You know.
Yeah, and some of it does come down to, you know, what are you trying to do? What is your use case? And then what is the easiest way to implement your use case, right? Because one way you can end up spending lots more time trying to do something that's very simple in the other way. So, yeah, things like transitive properties and things, when you look at, you know, how do you deal with cables? Transitive properties is really simple versus, you know, trying to create large linked lists side of things as well. So, but as I said, it's just, depends, I suppose, on, again, and it's a good discussion, right? Because the question really comes down to what's the experience across overall that needs to be pulled together from a knowledge aspect point of view to make those sorts of decisions, right? Rather than just one individual person. So,
yeah, but you know, you kind of have to start somewhere. That's the only thing. You know?
Yeah, I completely agree. You start somewhere and then you learn, right?
Yeah. This is why I suppose in the email thread I kind of said, you know, start simple. Start with RDFS, and you know, if you need more, you look at more.
Yeah, I think some of it is starting simple, could actually be starting with OWL, right? And I think, as Raphael said earlier, most people have used Protege, right? But Protege doesn't support RDFS anymore. So it's
Yeah,
all
so
OWL.
I'm sorry to interrupt. We're nearly out of time. There's a new
Yep.
show of hands for those who haven't seen it, and Thomas has patiently been waiting in the queue.
And hopefully you could stay 10 minutes longer for last series of questions. Thank you.
Yeah, I only have a quick remark. When I was listening, out on top of my head, I was thinking, like, I think we need to think about sharing knowledge between whom and for which reason. And I think once we determine that, and then basically the cases are coming, and I think from there we can develop.
Very good. The first poll was about the interest to work on knowledge graph. And yes, there is some interest. I'm wondering if there is more interest than just the authors of the different drafts, right? I'm not sure how to check that. The second one is IETF NMOP the right place? Some people said no, and it would be great to understand why. Is this because the IETF process is not the right one and that RFC is not the right outcome? If you want to comment on that, that would be great. The people who said no.
So me speaking as individual, I said no for that reason specifically.
Okay, and Rob and Nacho, but think also about, is there anything we need to change the IETF process to include this? Is this even possible, or is it just like a no? Rob?
So I think I didn't have the answer I wanted to give up. My answer is probably not yet, or not now, or not here. So one of the questions is this something that fits into the IETF versus the IRTF? And this still feels at the moment, I don't know what the exact experiment is that you're doing. I don't think that experiment is scoped down tightly enough to be a clear thing that should come into the IETF within the NMOP charter. Obviously no longer an AD. Whereas obviously you could scope this more towards an IRTF researchy sort of problem, although I don't know whether it would actually go anywhere useful there. So, however, I do think the underlying problem that you identified, Benoit, of the requirement to have to be able to combine different discrete data sets and schemas together and have a way of doing that is a problem that needs to be solved. So I'm a bit on the fence here, but that's why I voted no.
Nacho.
Yep, I also said no. The same reason. Not today, because as Michael said before, ontologies are living things, and the RFC processes are slow. No, in this sense, the IETF needs to evolve. We have seen this with Yang already, with what happens with the development of Yang data models. Here, I think the IETF would need to evolve to explore this. So maybe it's not the moment.
Okay. So trying to take, and Rashad, feel free to help me with this, trying to take all this into account. There are some people who want to telling that knowledge graph is interesting. Not sure if there are more people than there's the authors. There are mixed feelings about the IETF because of the fixed production of RFC, which is the end goal. So an idea that we were bouncing back between us, Rashad and myself, is, would it make sense that the people who are in favor of knowledge graphs, so basically the author of these documents, that we would have a kind of design team telling, can you guys self-organize? And if it's about sharing what you said, Lionel, sharing, but as Thomas mentioned, for which goal, between whom, and how do we share the incident? Or is this about tuning? It was Yang to all, Yang to RDF. And if you could, for example, mention what is success in a year from now, what is success in 2 years from now, and whether this is in NMOP or NMRG or somewhere else, then you would say, okay, this is how we could collaborate on this. Would it make sense? And Rashad, did I express this the right way as you wanted?
Yep. I mean, I think basically it might be mixed opinions as to whether the IETF is the right place to go, but I think the previous poll about it being work of importance was very positive. So we're trying to find a way how to move ahead with this.
Rafael.
Yeah, I just wanted to add one thing. So I do think that indeed here or around the table, there are plenty of people who have the right piece of knowledge, expertise, and will to sort of go together and like you say, self-organize and come up with perhaps a joint proposal in the near future. My only concern is, from my experience, is every people around the table have an employer, often a private company. Some of us are academic, some a bit more freedom. And there is obviously trade secrets and IP sharing that sometimes prevents completely open collaboration. And the good things about IETF groups or WCG groups, etc., is that it provides the vehicle that, legally speaking, offers room so that people can collaborate without having the larger corporation signing all sort of legal documents they will never sign, enabling this collaboration. So for me, I'm seeing NMOP or the like as an adequate vehicle to trigger this sort of organization. Now, if this is not the right home, that means we need to find what it could be. Just wanted to bring this point into the discussion.
Very good. So we're going to close the call in a few minutes. Any concluding remark? Any different opinions from our ADs or from someone?
I'm just curious. You know, if people say, okay, IETF is not the right place, where do they think the right place is? Where else do we go? Isn't this the whole point?
Valid question. Do we go to schema.org or somewhere? All right. So concluding with an open question is not a bad thing. That makes people think. So what would be very nice is that, okay, we've got like 3 documents with 3 different experiments, right? One being, I'm going to summarize very quickly, starting from the top-down incident with Lionel, starting with the Yang catalog with Nacho, and starting with the correlation of information bottom-up with Michael. So can the authors of these documents try to self-organize to say, okay, where do we work? How do we work? Is it just schema.org? Is this IETF? What should the IETF be doing? Changing the process, etc. Just a plan, regardless of where we do this. I think it will be going a long way. All right, so I see a couple of people
nodding.
nodding.
Yeah, and I think that the Madrid end of July meeting point could be a nice checkpoint.
All right, very good. Then I propose that we close with this. Maybe we're going to, the 2 chairs, we're going to send some more questions to the people, the mailing list for people to self-organize. And you just all volunteer to get a slot in Madrid to provide your answers to this question. Thank you very much.
Thank you, everyone.
Delegate, Benoit, delegate.
Thank you.
Thank you. Bye-bye.
Thank you.